Hey everyone, it's Justin again. In this unit, we're going to be learning about some new types of functions and their graphs, starting with a type called absolute value. Make sure you've got some graph paper available because this unit will have graphs in every single lesson. Absolute value itself is a fairly straightforward function. The function is written using these vertical bars to denote the absolute value. It's kind of like a special parenthesis. This would simply be read as f of x equals the absolute value of x. What the function does is it measures the distance of whatever x is from 0. For instance, the distance from 0 to 5 is just 5. And the distance from 0 to negative 2 is 2. If you're confused as to where the negative went, think about how distance is measured. A ruler only has positive numbers. You can measure 2 feet in any direction and it'll still just be 2, not negative 2. Distance is always positive. So in its base form, absolute value will always come out positive. There is one exception to that rule. What's the distance from 0 to 0? Well, they're the same number and the same point on the number line. So there's no distance, 0. Technically, this isn't positive, but it's not negative either. It just means instead of a positive distance, there just isn't any distance at all. So what would this look like in a graph? Well, it's just as simple, really. Let's try a few points. First, if we know the input is 0, the absolute value will be 0. If we use 1 as the input, the distance from 0 to 1 is 1. And if we input 2, the distance from 0 is 2. We can already see how this is going. Every positive input is its own output. But remember, absolute value does something different with negatives. The distance from negative 1 to 0 is not negative 1. Distance can't be negative. Instead, the absolute value of negative 1 is 1 because it's 1 unit away from 0. Likewise, negative 2 is 2 units away from 0, and this pattern will continue with every negative input having its own positive output. So now we've got a pretty good idea of what this graph will look like a giant V. That point where it suddenly changes directions is called the vertex. You've heard me mention absolute value's base form a couple times now, and that's because there's a lot more to it. There are other variables that can change what the graph will look like. In its base form, just the absolute value of x. The variables don't change anything. The multiplier a is 1, and multiplying by 1 doesn't do anything. And the constants h and k are 0, because adding or subtracting 0 doesn't do anything. So in this base form, nothing is being done to the absolute value function. But if we start messing with those variables, they can make it do some weird things. In the next few lessons, we're going to explore what each of the variables do to the function. First, let's look at the constants, h and k. K is a little easier to understand, so we'll start there. K causes what is called a vertical shift. In other words, it moves the graph up or down. Fortunately, it's pretty easy to tell which direction it goes. A positive value makes it go up, and a negative value makes it go down. Let's look at an example. Here, we've got a basic absolute value function, and here is that same absolute value function with an additional plus 2 at the end. That plus 2 is in the place of k, meaning it will cause a vertical shift. A plus vertical shift moves the graph up. But just adding 2 at the end, we managed to move the entire graph up by 2 units. If instead we subtracted 3, the base function would be moved down 3 units. Next, let's look at what h does. H's role is to create horizontal shifts, meaning it moves the function left or right. Just like with k, the directions seem obvious. A positive h moves the graph right, and a negative h moves the graph left. But there's a catch. That negative before the h means that its true sign is often hidden. Let's take a look at an example to see why. Here's our basic absolute value function again as a baseline so we can see what changes. Let's see what happens if we add 2 inside the absolute value. If you thought it would move to the right, then you'd be wrong. The reason is that pesky subtraction sign before the h. If h was 2, then the function would read x minus 2. But the function is x plus 2, which means h has to be negative 2, so that x minus negative 2 will become x plus 2. This is why the minus h can get confusing. The sign of h is the opposite of what you see. So what if we have x minus 4 inside the absolute value? With this function, we are subtracting positive 4. So h is positive. We move to the right 4 units. From now on, it will be super important that you remember that horizontal shifts go in the opposite direction of the sign you see. Multiple transformations can take place at the same time, too. For instance, we can add 4 on the inside and subtract 1 on the outside. This means that the graph will shift left 4 units, because that really says x minus negative 4, and it'll shift down 1 unit. So the absolute value of x plus 4 minus 1 will look like this, with its vertex shifted left 4 and down 1. So k causes vertical shifts, and h affects horizontal shifts. But what about a? That multiplier a does something a little different from h and k, so we're going to wait to learn about that in the next video. See you then!